Hello everyone, welcome back to class again. How are you doing? I believe you are all doing fine. Today we are still going to continue from where we stopped last week, and that is, remember, methane has a structural formula of this, which is CH4. Methane is sp3 hybridized. Then methane, the angle between the carbon in methane is 109 degrees. Now, normally, if we want to draw methane in our notes or our book, we draw it this way. But if we view it, this is how methane looks like. So that is why the angle here is 109 degrees. Now, methane can be prepared in the laboratory by heating sodium ethanoate with what we call soda lime. Sodium ethanoate is CH3 COONA. Then our soda lime is a combination of caustic soda and also quicklime. You are wondering what that is, Abby? Okay, your caustic soda is sodium hydroxide, and your soda lime or your quicklime is calcium oxide. So the combination of the two is what we call soda lime. Now, when you take your sodium ethanoate and you react it, remember this is a solid, and you react with sodium hydroxide, which is also your caustic soda, in the presence of quicklime. Then you are going to heat the mixture to about 300 degrees centigrade, and eventually, let me explain what you're going to get. You are going to look at it. You are going to, this here are going to combine like this. Then what do we have? We have 2 Na, Na2. Then we have C. 2 0 here, 2 oxygen here, 1 oxygen here, making 3 O3, plus we have CH3 here plus 1 hydrogen, CH4, and that is our methane. So this is a laboratory preparation of methane. Then the question is now, why adding calcium oxide? Why making use of soda lime? The reason why they make use of soda lime is, number one, soda lime is not deliquescent. What do we mean by deliquescent? Deliquescents, they are compounds that absorb moisture from the atmosphere. So because if there is an absorption of moisture from the atmosphere, it's going to affect the reaction of such preparation. So, but soda lime does not absorb moisture from the atmosphere, and that is why we make use of it. Then also, soda lime does not attack glasses. You know, majority of practicals that we do in the lab, we deal with glass. So since soda lime is not attacking it, so it will not affect the result of our preparation. And that is why we make use of soda lime in the preparation of methane. So let us now look at physical properties of methane. What are the physical properties of methane? Number one, physical properties. Number one, methane is a colorless, odorless gas. Then methane does not react with a litmus paper. It means that methane does not change red litmus paper to blue, or from blue litmus paper to red. Remember, wet litmus paper. Then another property, physical properties of methane, is that it is slightly soluble in water. And when you look at the preparation of methane, that is why we collect it through water, because it is not soluble or slightly soluble in it. Then let us now look at chemical properties of methane. Majorly, alkanes, they have just two chemical properties. we have the one that we call substitution. Then we have what we call combustion. So let's quickly look at substitution reaction of alkane. When we say substitution, substitution is the reaction of alkanes with halogen, majorly chlorine. And in the process, the chlorine will displace or substitute itself with the hydrogen in alkane, thereby attaching itself to alkane group. What do we mean by that? Let me give you an example of this. We have CH4 methane plus Cl2. What will happen is one Cl will come and join the CH4 here, which is going to give us CH3Cl, then plus the hydrogen that the chlorine removed will combine with the second chlorine here, plus HCl. Now this is called chloromethane. It will continue like that until all the hydrogen has been replaced with chlorine. Let's look at it. We pick this one again, CH3Cl, reaction with chlorine again is going to give us CH2, Cl2 plus HCl, and this is called dichloromethane. Then we also take this one again, CH2Cl2 plus another chlorine to give us CH3Cl plus HCl. This is called trichloromethane. It can also be called chloroform. Then we have the last one, which is our CHCl3 plus another Cl2. So what do we have at the end? We have CCl4 plus HCl. And this one is called tetra. Tetra means 4, chloromethane. Now when you look at it, you can see that chlorine has eventually replaced all the hydrogen atom in methane. So that is substitution reaction. The substitution reaction of alkanes generally, it does not only apply to methane alone, it also applies to other members of alkane. So let us look at combustion. So combustion is when alkane burn in oxygen. And majorly when organic compound burn in oxygen, they give two things, carbon dioxide and water. So let's say methane reacts with oxygen in the presence of sunlight. What do we have? We have carbon dioxide and water. This is going to be 2 air, and this is also going to be 2, correct? So this, when alkane generally burns in air, you're going to have carbon dioxide and water, and those are majorly the two chemical properties of alkanes. So let us look at uses of alkane. What do we use it for? Number one, methane is used as fuel. Can use methane as fuel. It can also be used in the preparation of hydrogen. Also in the preparation of chloroform. Which is what? Trichloromethane. So that is that about that for this class. Next class we are going to look at alkenes, then also how to name an organic compound.